This meeting is being recorded.
This next problem from Chapter 8, number 21, we're given some information about a compound called alpha-pinene. And as you can see, it has that ene ending. It is an alkene. So it will react as we've seen in the past. In this case, when we have hydroboration, oxidation occur, we're going to be able to select for what's referred to here as the negative enantiomer. So this is the background, right? So this is what was done. This negative alpha-pinene was used, and we have this hydroboration, oxidation reagents listed here. Instead of this combination, the borane and THF, diborane is used. That was the dimer we discussed that borane could itself become, when borane interacts with borane, we get diborane, and that can be used in place of BH3 and THF. So we know that we're going to have a hydroboration oxidation, so we know that we're going to have anti-Markovnikov addition across our pi bond, and that will be where H goes to the less highly substituted carbon, OH. H will go to the more highly substituted carbon where more hydrogens are, since it's anti-Markovnikov, and then our OH will go to our less highly substituted carbon. So let's take a look here. If you can imagine that these molecules down here, the double bond has been broken. So where I just placed that red squiggle, these are our two possible products drawn out below here. So again, we have syn addition when we have hydroboration oxidation. When we have these chiral centers created, we know that our H and OH will add from the same side. And I've tried to indicate that in red. So I have the addition from this plane, right from the bottom, where we have addition over here from the top. So our CH3 and our hydrogen on the other side of the bond that was there initially, that's drawn in black. And we can see that the H and OH has added to the bottom on this molecule here. So the plane below our pi bond is another way to express that. And we're asked to draw both products. So that's what I've done ahead of time here is drawn both of these products. And then we want to know which is the major diastereomer. So these are not enantiomers, these are diastereomers. And the major would be this one over here. And I will explain why. This guy over here is the minor product due to steric hindrance. So the larger group, the OH, right, that's adding, would add from the bottom here when there's this bulky group over here that causes that steric hindrance. So this would be our major product due to steric hindrance. And this would be our minor product over here where this bulky group interacts when the OH adds. It causes just a lower percentage of that product.